Uh, Good morning, everyone. Let's continue with our discussion on probability and statistics. We have already discussed about, we are in the process of discussing random variables. We have already finished discussion about discrete random variables. So let's take few examples on continuous random variables and see what we get. Okay. So let's take this example. What we have is let x be a continuous random variable. Sorry, my bad. It's a continuous random variable. Okay, with the probability density function with PDF probability uh, distribution function f of x, right, is equal to we have ax where whenever x lies between 0 and 1, it's a constant when x lies between 1 and 2, and it's minus ax when x lies between 2 and 3. What we want to check is find probability of, first of all, find a, of course, find a, what is a, 1, 2, find probability of x when it is less than 1.3, less than or equal to. So well, let's do this quickly. Right, so how do we do this? Right, one thing to do is we see that the total probability, right, the total probability is 1, right? So how did we kind of define the total probability, right? If you look at the total probability from minus infinity to infinity of any f of x, where f of x is a probability distribution function, is 1, right? But if you notice this function, it's 0 everywhere except for the interval. So if I look at if we little bit have it's not a very huge idea. If I look at this, here it is 0, right? This is 0 to 1, it's defined to be something ax. Then 1 to 2, it's defined to be equal to a for some a, and from here this is defined to be minus ax, right? 2 to 3, right? And it is 0 again here, right? So I don't have to worry about all the points before 0 and after 3, right? So what do we have? Therefore, since let's write down, since total probability is 1, that means the area under the probability curve, we have already seen that the area under probability curve is 1, isn't it? So therefore what we have is integral from minus infinity to infinity f of x is 1, but minus infinity to infinity would be just restricted to 0 to 3, right? So because every apart from bigger than 3, the function is 0, less than 0 it's also 0. So this is 1, right? This would imply that f of now this is defined in different ways, right? So let's break this integral. So 0 to 1, it's defined to be ax dx, plus 1 to 2, it's defined to be a dx, and from 2 to 3, it's defined to be minus of ax, right? Now we know that integral of, just if you know the formula, integral from a to b, right, x power n is nothing but x power n plus 1 over n plus 1, and then you put the limit in place of, right? So what will be this? This would be 1 over n plus 1 in the bracket b power n plus 1, right, minus a power n plus 1. That's the formula to evaluate this, right? There's some alpha constant, right? You can take alpha out, and this would be, in that case, if there's alpha coming out, then the alpha will come out here. This alpha would be here, alpha would be here, right? That's the formula, right? If you know, right? So what we get in this case is this would be equal to 1, right? Therefore what we'll get is, if I use the integral, this will be a outside, right? And then if I use the formula, n is equal to 1 here, so this will be 2, right? Isn't it? And in the bracket, what will happen is I will get x squared, right, upon n plus 1, that's 2 already taken, and it is from 0 to 1. Plus there's no x here, so the power of x is 0. So put n equal to 0 here, so what you get it is x, right? And this is from and then a is out, right? 1 2 plus minus a comes out, and then x, so again you get x square by 2, and then this is from 2 to 3, right? This would and this is equal to 1, of course. This would imply that this is like a by 2 outside. Use the formula. This is equal to take this out. This is b raised to n plus 1. So this is b here is 1. So 1 squared minus 0 squared, right? Plus a times 2, right? 2 put in place of x 2. 2 raised to 1 is 2 minus. And here what will happen is you take minus, that's a minus sign there, so you've got to be careful. So this would be minus a by 2 out, and this would be 3 square minus 2 square, right? So if I simplify this, and that's everything equal to 1. Now if I simplify this little bit, this would be a by 2, right? Because 1 square is 1. 2 minus 1 is 1, so this would be plus a, and negative would be 3 square, right? 3 square is 9, isn't it? 3 into 3 is 9, 2 into 2 is 4, so this would be minus a by 2 into 9 minus 4, that is 5, and that's equal to 1, right? This means now this is a by 2 minus 5 times a by 2, right? 5a by 2 plus a equals 1. Now this is like you subtract 5 from a, right? 5 from 1. So a minus 5a is nothing but minus 4a. If you little bit know the how the addition or subtraction works, this is minus 4a over 2 plus a is equal to 1, right? What does this imply? This implies to us that this would imply that this would be minus 2 times a plus a equals 1. This would imply that a is equal to minus 1, right? If we have done the calculation correctly, right, then I should get a equal to minus 1, right? Isn't it? Then therefore wait a second, I think I have done an error because I get a to be negative. That is a problem. That would be a problem, because in that case I will get probability to be negative, right? That cannot happen. That cannot happen if I get a to be negative. So at some error I have done. Oh yes, there's small error here. This is little bit error. This is plus, there's a term here. I hope that's rectified. This is plus 3a, right? So the only difference, I'm sorry about that, I didn't realize the question was taken to be wrong. So the only difference here would be man, so anyway, I beg your pardon because of that. I just made an error I've done. This is plus what a is it? Is it 3a? So the nothing would change apart from some calculations. So 3a, right? So let's just little bit kind of change this. Some little bit of calculations would be more, but apart from that, things are fine. I beg your pardon because of that. Let's just quickly make the calculations, right? Put this and do the same kind of calculation, right? So what you get is this would be minus, this would be same, this would be minus 5 by 2, right? That's what we have got earlier. And then there's extra term here, so this would be plus 3 minus 2 is 1, so this will be 3, that's equal to 1, right? So this would be, you take hit here, this would be minus 5 of a, right? Sorry, minus 5 by 2a, right? Minus 5 by 2a, right? And minus 5 by 2a, and this will be plus 3a and plus a. So this will be minus 4 plus 3a plus a, that's 4a. So that's what the error was. So this is what you get, plus 4a minus 2a, right? This would be plus 2a equal to 1, right? Therefore what you get is a equal to 1 by 2, right? Now that makes sense, right? That's what I was wondering, how on earth am I getting negative answer? Okay, right? So because remember, probability is always positive. Now with that said and done, we are in the quest, right? So therefore, therefore the answer of the first question is a is equal to half, right? What about this question 2? We need to find what's the probability of x which is less than 1.3, right? So this is like this is equal to minus infinity to 1.3 f of x dx. But this is not defined from, I mean, the function is defined from minus infinity to 0 as 0, right? So only it's from 0 to 1.3 f of x, because before 0 the function is defined to be 0 if I look at the function, right? So therefore what do I get? What do I get? Let's see. What do I get? What do I get? Let's check out. So this is equal to, now the function is defined from 0 to 1 and 1 to 2, right? So this is equal to, let's write this, 0 to 1 f of x dx plus 1 to 1.3 f of x, right? How the function is defined to be from 0 to 1, it's defined to be ax, but a is half, so this is 0 to 1, 1 by 2x dx plus 1 to 1.3, the function is defined to be a, isn't it? 1 to 2 it is defined to be, so wherever it's 1 before 2 and bigger than 1, the function is defined to be a, so this is half dx. So this is equal to half, right? This is again use the formula, this is x square by 2 from 0 to 1, and this will be 1 by 2x, right, from 1 to 1.3, right? This is just mere calculation, so this is half 1 squared minus 0 squared plus half 1.3 minus 1. This is like 1 into half, that's half, plus half it 1.3 minus 1 give you 0.3, isn't it? That would give you 0.3. So this is like 1 into 0.3, right? So this is like 1.3 over 1 plus 0.3, right? Because this will be 1 into 0.3, so it will be 0.3, so it's 1.3 by 2, right? That's the answer. I hope that's clear, or I have done, yeah, just do these errors, you see. I just realized that this is 2 into 2, this is 4, so this would be 4, so I'll have to multiply this by 2, so I'm sorry about that. This calculation is the thing which I'm bad at. So multiply 2 here, so LCM is 4, right? So this is 1 plus this is 0.3 into 2 gives me 0.6 if I am correct, right? Because this 3 into 2, 6 into minus 10 raised to minus 1 would be 0.6. So this would be 1.6 by 4. And then you can check what is this answer, but then you can leave it up till here, right? So that's the answer for the second question. Okay, so let's look at more things. Uh, let's look at continuous distribution function. Okay, continuous probability distribution function is uh, by f of the random variable less than or equal to x from minus infinity to x ft. So there are some remarks or notes you would wish to take. First one is, if I differentiate this, I get my f of x, right? So let's do that. df by dx. Second one, what happens if I put f at x equal to minus infinity? F at minus infinity would be integral from minus infinity to minus infinity, right? Whenever you have integral from definite integral from a to a, that's always 0, right? So that's 0. Why? Because this would be, I hope you know certain ideas at least. Minus infinity to infinity, minus infinity f of t dt. That's 0. And third one, f at infinity would be minus infinity to infinity f of t dt. That's one. we have about that. Fourth one rather, whenever we're gonna find probability of A less than X less than B, and this is just like you get this from minus infinity to B, then you get f of t negative A to infinity, some use of result from integration. So let's look at that. F of B minus f uh, probability continuous probability distribution function is given, then you just have to plug, and you need to find this, and you need to plug B and A, and then look at f of B minus f of A, and you get the answer. So want to do in this, just remember this formula. Look at exactly get and how to get. Just remember this formula as long as possible. It's more than enough. Uh, look at code. Uh, given x equal to 0 whenever x is less than 0. It's defined like this. Let's look at that. Uh, x whenever x is between 1 and 0. Uh, 0 when x is positive, greater than 1. So wherever x is 0 here. So let's kind of draw that 0 here, right? From x equal to 0 is 1. Till x equal to 1 included. Then for n greater than 1, it's again 0. X greater than 1 is again 0. So that's my function. For that, so f is a area, probability density. Okay. So the function, probability density function is a probability function. I need a get formula. You know that d by dx of f of x, small f of x. So I have f of x. If I need f of x, I just have to differentiate this, right? So what will be that? Therefore, f of x would be equal to this would be 0 anyway when x is less than 0. Derivative of x, that's 1. 0 less than x less than 1. And here anyway it's 0. So therefore, integral minus infinity to infinity f of x, same as integral from 0 to 1, because this is 0 anywhere, everywhere apart from that. So that's f of x dx, right, which is 0 to 1, 1 dx, which is x from 0 to 1, right, which is 1 minus 0. Therefore, what do we get is, therefore, and accordingly, the given function is a probability If f is PDF, remember if d by dx of f of x, this is f of x, and you can show that if this is PDF, right, this f is probability. So the question here is that probability distribution. Sorry about that. So if this is PDF, so if you look at the derivative, you show that this is PDF, right? PDF as in you show that the integral from minus infinity to infinity f of t is 1, then this becomes PDF. This is PDF, then this is the corresponding f of x, whose derivative is PDF, is this is nothing but a probability distribution. Uh, okay. Next, yeah, example, continuous distribution function, probability distribution as PDF. F is here and it's between 0x, 0 x and equal to x plus 1. If its is half, mean is half, remember mean of this problem, we know what is mean, right? Mean of a continuous probability distribution is given by integral from mean of between this e, e mean of the probability distribution function f between a and b is given by a to b x f of x dx. Well, remember this. When we do expectations and all, but it's a mean. Remember this. Therefore, if mean is half, right? Solution, we got to find what is a and b, right? Do that. So mean is equal to integral from 0 to 1, right, function x times ax plus b dx, right? Uh, and that's equal to that's given to be half, right? And this is 0 to 1. This will be ax squared plus bx, isn't it? And then dx, right? We know the formula. What's the integral of what's the integral of x power n again? Dx, of course, it's x power n plus 1 upon n plus 1. The constant doesn't really matter. It just can be, if it is a here, just stays there. So what do we get? This would be, and then there's limit. If there's a limit from a to b, then you have to take the limit correspondingly, right? So that constant is out. What's the integral of this? This will be x cube over 3, right? N plus 1. N is 2 there, right? You observe carefully. And this would be bx square over 2, and this is over 0 to 1. This is over 0 to 1. So this would be uh, a 1 cube minus 0 cube by 3 plus b 1 squared minus 0 squared by 2. So this implies this is just simply a by 3 plus b by 2 equals to half. Then I can just multiply this here, and what you get is 2 times a, multiply it here, multiply this here, and then multiply both here. This will be 2a plus 3b equals 6 by 2, that is 3. So I get one equation, right? But I have two constants. I need another equation. F of x is given to PDF, means f of x is given to be the PDF, right? Given to be PDF. This would imply that integral from minus infinity to infinity f of x is 1. But this is defined over minus 1 to 0 to 1. So this implies 0 to 1 ax plus b, isn't it? Dx is 1, isn't it? This would imply that ax squared over 2 plus bx, right? 0 to 1, 0 to 1 equals 1. This would imply this is a, this will be 1 square minus 0 square, which is 1 by 2. And this will be b into 1 minus 0, that's b equals 1, implies a plus 2b. If I just multiply 2 here and 2 here, what I get is a plus 2b equal to 2. So this is 1, and I get equation okay, this can be 1 and this can be 2 for me, right? Now I have two equations. I can solve them all day long, right? Let's look at the equations. I have 2a plus 3b equals 3, if I'm not wrong, right? And a plus 2b equals, little bit of calculation tells me that I can solve this simultaneously. Everybody knows how to solve simultaneous equation. Multiply this by 3, make either coefficient of a common or coefficient of b common, right? So that you can subtract. You can multiply this by 2, so this implies what I get is 4a plus 6b equals 6, and this would be 3a plus 6b, right, equals to the second unit. Now just check out. Did I made a mistake? A plus, this would be 3a, multiplying this by 2, right? Boy, how can I make a mistake like that? So what do we get is this will be 6. Okay, all right, it's fine. So if I subtract, what happens is this gets cancelled. What happens is I get a, 4a minus 3a is a, and this is 0. Therefore, a is 0. If a is 0, b is 1. As simple as that, right? Therefore, what do I get? My function f of x is just, if I look at the mean right now, just verify, mean would be integral from 0 to 1 x into 1, which is x square by 2, right? 0 to 1, which is just to verify, right? So that's what. Let's next look at mathematical. So let's look at mathematical expectations. So what are mathematical expectations? All right, let's see the definition. So if x is a random variable, and then variable, right? Uh, which assumes any of the values, x1, x2, so on up till xn, with respective probability distribution, probability distributions, respective probabilities we can take rather than respective probabilities, probabilities, right? Okay. Probabilities, p1, p2, so on up till pn, right? Then the mathematical expectation, and the mathematical expectations of x, mathematical expectation rather, mathematical expectation of x, right? Denoted by ex, right? Capital Ex, right? Is defined by, is defined as, is defined as ex, ex equals p1 into x1 plus p2 into x2, right? Plus so on up till pn into xn, which is nothing but, if I write it in the closed form, it's like I going from 1 to n, xi into n, right? Where we know that summation pi, I going from 1 to n,
which is equal to P1 plus P2 plus so on, all the probabilities, right, should be equal to 1, isn't it? Right? So, uh, that's the idea. And what's this sum? The sum is taken, similarly, this sum anyways is taken over all the values of, let's look at uh, something uh, more of this physical interpretation, of EX. What does it mean for us? Um, so let us consider, let us consider following frequency table, following frequency distribution, following frequency distribution, following frequency distribution of a random variable x, of a random variable x. Let's draw tables. Oh, let's fill in the values. Let me take this to be x, and this is f, right? So this is x1, x2, x3, then dot, 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 so on up till xn. The corresponding frequencies are f1, f2, f3, so on up till fn, right? Then the mean distribution, we always know how to find mean, right? With the probability which we have studied so far in previous classes. Then the distribution, mean distribution is given by, you have to multiply the frequencies to corresponding values of x, right? That's how we know when we have mean is denoted by x bar, right? And it's given by f1 x1 plus f2 x2 plus so on up to fn xn, right? And then you divide that by n, which is nothing but, look at this, it's like f1 by n x1 plus f2 by n x2 plus so on up till fn by n. Then name this as some equation. Maybe star, I'll name this, where n is nothing but summation fi, which is equal to f1 plus f2 plus f3, so on up to fn. It's a formula to find the mean for a given frequency distribution. Isn't it? But we know that, okay, so from here, we observe that, um, let's use different from pen, we observe that if I look at the corresponding um, expectations, right? It's like P1 x1, P2 x2, P3 x3, so on up till Pn xn, isn't it? Right? And if I compare this, let me name this as something, right? Let me some hash, right? If I if I look at hash and if I look at star, then what would we observe that of n cases, out of total of n cases, total of n cases, fi cases, right, are favorable favorable xi. Therefore, what happens is probability of x is equal to x. is equal to fi over n, which is equal to x I, right? Where I put n. Or sorry, not xi rather, it's pi. Isn't it? Pi, right? Where I is equal to 1 to n. So what does we get? What do we get? We get this to be, this would imply that P1 is equal to F1 over n, P2 is equal to F2 over n, P3 is equal to F3 over n, right? So on. Um, Pn is equal to Fn over n. Um, we get hence from hash and star get x bar is equal to x1 p1 plus x2 p2 so on plus x n pn. And what is this? This is nothing but, what was this? This was mean, right? So what do we have? Expectation, random variable, mean, right? The distribution, isn't it? What is the problem? We find my expectation is exactly the mean. So write down hence by expectation mathematical expectations of a random variable, right? Right? Or we can say hence the mathematical expectation rather. Word hence the mathematical expectation of a random variable, right? A random variable is its mean. Um, what do we get? Mathematical expectation of a random variable is mean, isn't it? It's, that's the idea of probability distribution, and there's a relation between mean and probability. I mean, mean and expectation. Let's quickly solve an example, right? So the problem is if we roll a die, randomly, okay, we need to find the mathematical expectation of the number on it. Okay, so how do we find this? Okay, so uh, so let x denote, right, number on the die, number 10 on the, x can take the value, then x is a random variable, then x is x is a random variable and x is a random variable, discrete random variable, guys, right? Random variable get which can take any one of the values 0 1, oh, sorry, mistake, 1 2 3 4 5 6, right? 1 2 3 4 5 and say that 1 2 3 4 5 matter 1 2 3 4 5 6, right? And probability of getting any one of this, and probability with equal probability equal probability of 1 by 6, right? If I look at the table, I'll just draw it with my This is like 1, 2, 3, 4, 5, right? So this is like x values. This is p of x. This is 1, 2, 3, 4, 5, 6. So it's a probability of 1, 1 by 6. Probably getting a 2, 1 by 6, 1 by 6. Everything is 1 by 6 equal. Uh, um, Probability, right? Therefore, what will be mathematical expectation? Simple as that. Therefore, e of x, right, is nothing but summation x into p of x, right? So what is this? This is like, if we open up this, this is 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6, right? Write down that properly. 3 into 1 by 6, 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6, right? Which comes out to be, if I take 1 by 6 common, there will be 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? So how much this is? This is 1 by 6 into, this is 3 plus 3, 6, 6 plus 4, 10, 10 and 11, that's 21, right? This is 21 over 6, which can be cancelled out to get 7 by 2, right? So approximately corresponding. So we'll solve more examples, but before that, we'll take some theorems, right? Okay.
So let's look at the following theorems. The very first theorem, so let's write down that theorem on expectations. Theorem on expectations. Okay. Um, so the first one is, I'm not going to prove this or something. Expectation of constant, right, is is equal to itself, right, where c is a constant, right? One can prove that where pretty easily. What is expectation constant? That's mean, right, uh, of c, right? What's mean of constant, right? That's c plus c plus c plus c, whatever number of times, over n. This is n times c over n, which is c, right? So that's nothing, uh, right? The next one is expectations of a constant multiple of x is constant multiple of expectation of x, okay, where c is constant. One can similarly prove that. So what will be expectation of cx, right? This would be equal to cx1 into p1 plus cx2 into p2 plus so on up till cxn into pn over the n. Just made a mistake here because I'm sticking with capital N, right? So, uh, so let's not change the notation, then you'll be wondering what's this is capital N times C over N, and then this gets cancelled to be giving me C. Uh, so, but I can take C common, right? And then I can get this is x1 p1 plus x2 p2 plus so on till xn pn and then over n, right? And this is nothing but c times this is the definition of ex, right? So that's the second one, right? The third one is you can directly prove that expectation of ax plus b is is nothing but a, using the properties here. Uh, one can prove that expectation of ax plus b is nothing but expectation of a into x, I mean a into expectation of x plus b, because anyway expectation of b b itself, right? Because b is constant. So where a and b are constant, one can show this quickly. I'll leave it to you. Then we'll have addition theorem. Fourth one. addition theorem of expectations, addition theorem on expectations. What does it say? If x and y are random variables, let's write that. If x and y are random variables, x and y are random variables, then expectation of x plus y, right, is equal to expectation of x plus expectation of y. Okay, so what does it mean? That is expected values of sum of two random variables, x and y, right, is equal to sum of their expected values, is equal to sum of their expected values. Okay, that's what the theorem says. Fine. You don't have to prove this. And if I club with the fact that expectation, this is 5, right? If I club them with ax plus by, right, with the fact that a comes out, then this is a expectation of x plus b expectation of y. Nobody, I mean, you don't have to prove this, but just where a and b are constant, where a and b are constants. Sixth one, it's multiplication theorem on expectation, multiplication theorem on expectations, right? So what does it mean? Whereas if, so let's underline this, if x and y are random variables, then expected value of product of these random variable is same as the product of their expected values, e to x e into 1. That is the expected value of the product of two random variables is equal to product of their expected values, right? That's what we have, right? By the way, I have missed the part here that they are independent random variables. Not independent, then this fails. So it can, I just missed that part that they are independent random variables. So expected values of product of two independent, right? I missed that part. You know that they don't. This would not work if x and y are not independent. Okay, uh, right? So if for multiplication theorem, x and y should be independent random variables, right? They should not have anything in common. Anyway, uh, well, that's what we have. Um, okay, let's look at the formula for variance. Okay, with respect to mathematical expectations. Okay, uh, just write down that variance of um, a distribution variance, you know that, and what variance means. So we'll write down that remark. Okay, variance, right, is calculated by with respect to probability distribution. It's e power x, p of x square minus p of x, the whole square. Right? So this is how you calculate the variance of a probability distribution. Okay. Then there are other results on variance. We would not bother doing that. Uh, this is fine for us. Various same for Taylor constant multiple and all these things. We would not bother doing. So that's what we have. Let's finish up these ideas with couple of more problems on random variables, right? Maybe three or four. I don't know. Let's look at quickly one by one. Okay, I have some problem lined up. Okay, so let's look at this problem. A random variable x is defined to be the sum of the faces, right? When a pair of dice is thrown. So you're throwing two dices, okay? Then you got to find the expected value of x, okay? So when two dices are thrown, what are the possibilities for x? Okay, so let's look at this one. Solution, okay? Let the random variable x, let the random variable x, right, let the random variable x, right, denote the sum of the sum, right, of the points, right, sum of the points obtained on the pair of the obtained on pair, right, of dice, okay, right. uh, so what will we get when we throw two dices? Let's draw a quite a big table. uh, Not proper, then I'm sorry, because I don't have that skill to draw straight lines, but um try, okay. So this is x, this is p of x. So let's write down first of all, this is when I throw two dice, what can be the sum? When both have 1 1, right, it will be 2, right? When then 3, then I can get 4, then I can get 5, and I get 6, I can get 7, I can get 8, I can get 9, I can get 10, I can get 11, and I finally can get 12, right? I cannot get anything more than 12, isn't it? Because the very simple fact that I have only 6 and 6 together, when I throw the dice. Right. Okay, what are the probabilities? We gotta check out. When I throw two dices, the probable sum which I'll get to be 2 is just 1, right? And total outcome when I throw two dices would be 6 into 6, that's 36, right? We know that total uh, outcomes are 36. Then when do I get 3? I get 3 when if I get 1 on the first dice, 2 on the second, or second on 2 on the 2 on the first die, 1 on the second. So there are two possibilities here, right? So 2 by 36. What about 4? I can get 1 3 or 3 1, or also 2 2 on both, right? So that would be 3 over 36. I hope I'm correct on this. Okay. Then 5 I can get 4 1, right? 1 4, right? 3 2 or 2 3, right? So there will be 4 over 36, isn't it? For 5, um, I hope I'm going in a correct direction. 6 I can get 5 1, 1 5, 4 2, 2 4, or 3 3, right? So together they would be how much? 5, isn't it? 5 over 36. Then 7 I can get to be 6 1 1 6, then 4 3 3 4, right? And 5 2 and 2 5, isn't it? So I would altogether get 6 by 36, right? So you can see 1 2 3 4 5 6, 8 I can get as 6 2 to 6, 3 5 5 3, right? And yeah, I think that's it, isn't it? I'll get 4 2 4. Oh, wait a second. 6 2 2 6. Then I can get 5 3, 3 5, right? And 4 4. So that would be 5 over 36. Okay. To get 9, I should get 5 4 4 5, right? 6 3 3 6, right? So that would be 4, isn't it? This is 5, by the way. I hope that thing is clear. That's 5. um, then this would be 4 over 36. Then I can get only like 5 5 on both, right? You see, 5 here, 5 there, or 6 4 4 6. Uh, so this would be how much? Um, where am I making mistake? 5 5 here and there, and 6 4 4 6. So 3, right? 3 by 36. 11 I will get only one twice, because 6 5 5 6 is 2 by 36, and here I should get. So it's like kind of, it goes like, you know, it's 1 2 3 4 5 6, and then 6 5 4 3, whatever it is. Okay. Therefore, what do we get? E of x, that's expected value, is nothing but sum of x into p of x, isn't it? That would be 2 into 136. So what I can do is I can just take 136 common, rather than multiply. Okay, I can do that and take common 136, right? Plus 3 by 3 into 2 by 36. Oh, just let me just do that better. Just take 136 common from everywhere, right? So this would be 2 into 1 plus 3 into 2 plus 4 into 3 plus 5 into 4 plus 6 into 5 plus 7 into 6 plus 8 into 5 plus 9 into 4 plus. So this would be 7 into 8, 8 to 5, right? 9 into 4 plus 10 into 3. Just check my calculations. Plus 11 into 2 plus 12 into 1, right? This would be 1 over 36. If I can write this, what we can do is, this is like, I can, well, let's multiply rather than actually doing this thing. So 2 into 1 is 2, plus 6 plus 12 plus 20, right? Plus 30 if I'm right, plus 7 into 6, right? uh, so 42 plus 40 plus 36 plus 30 plus 22 plus 12, right? How much this would be? This would be equal to 1 over 36, right? This would be 8 20, 20 40 70, 70 and 40 is 100 and 110, 110, 152. This must be, how much is this? For a second. Wait, this is 20 20 40 40 30 70, 70 40 is 110, 110, so 152 up till here, plus this is how much? This has to be 36, so this would be 66, 66 and 66 and this would be 22, that would be 88, 90, 100, right? This would be 100, so this comes out to be 252 over 36 if I'm not wrong, right? Which is equal to 7. Okay, so uh, let's look at this problem. From a bag containing 4 white and 6 red balls, 3 balls, uh, 6 red balls, 3 red balls are drawn at a random. Okay, so 3 balls, I beg your pardon, 3 balls, 3 balls are drawn at a random. Okay, what we want to do is we want to find the expected number of white balls, and then second question is, if each white ball carries a reward of rupees 4 and the red ball carries a reward of rupees 6, then what's the reward of the draw? Okay. So, let's kind of look at the solution of this quickly, right? So, solution of this solution. Okay. So there are how many white? Four white and six red balls. So there are 10 balls in the bag, right? There are 10 balls in the bag. Um, three balls, right, from the bag can be drawn in 10C3 ways, right? Isn't it? Right? Which gives the exhaustive number of outcomes. Which gives the exhaustive number of cases. Exhaustive number of cases, right? Which gives the number of, exhaustive number of cases, right? Uh, then, then, uh, the favorable number of cases, right, to the white balls, and consequently the red balls would be okay. Let's look at this one. Uh, so uh, in a random draw, right? Uh, the number of favorable cases, the number of favorable cases, right? Number of favorable cases for getting X white balls, white balls, and I'm picking 3, right? And 3 minus X red balls, right, is given by, um, so this would be equal to 4 balls are white, so this will be 4CX, right? Picking up X, um, you know, balls from there, and then together into 5, sorry, 6, right? 6C 3 minus X. We know this, right? Into 6 is given by, this is the favorable number of cases, so 6C 3 minus X, isn't it? Right? So let let P of X denote the probability of drawing X white balls, X white balls, right? Uh, by the way, here X is nothing but 0, 1. I can draw no white ball, one white ball, two white ball, all three white balls can be drawn, right? So therefore, what do we get? P of 0, no white balls. That's 4C0 in the all three red, right? So 6C3 over 10C3. So this is 6C3 over 10C3, which kinda comes out to be 5 by 30. Okay, just check that out. And P of 1, that's 1, 6C2 over 10C3. This is 4 into 6C2 rather, right? 6C2, isn't it? 6C2 over 10C3. If we'll do a little bit of calculation here, it comes out to be 15 by 30. P2, right, would be 4C2 multiplied by 6C1 over 10C3. And this comes out to be 9 over 30. And lastly, this all three are white, would be 4C3 over 10C3. This comes out to be 4 over uh, well, that's 4 over 120. That's 1 over 30. Okay, right. So check that out. Therefore, 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 the probability distribution, right, of number of white balls, number of white balls, number of white balls, right, drawn, right, that's the random variable x is, how would be the probability distribution looking like? 1, 2, 3, 4, 5. This is x, this is p of x. So this is 1, 0, 1, 2, 3, and this would be what? 5 by 30 is what we got first. Then 15 by 30 is second. Then 9 by 30, and then 1 by 30, right? So what? Therefore the expectation, therefore E of x, right, expected value, right, of white balls drawn would be summation x px, right, which is nothing but 0 into 5 by 30 plus 1 into 15 by 30 plus 2 into 9 by 30, right, plus 3 into 1 by 30. So if I take 1 by 30 out, okay, this comes out to be 15 plus 18 plus 3. So how much is this? 36 by 30, right? Just check that out. So this comes out to be somewhere around 6 by 5, so 1.2, right? Um, and then look at the next question. Next question is interesting. Um, it says that the reward for white ball is 4 and reward for red ball drawn is 6, right? Uh, so let's write down that also. Okay. Um, so second one here, since the reward on white ball drawn, is rupees 4, if I'm not wrong, and each red ball drawn, right, is rupees 6, right? Therefore, reward Rx for drawing X amount of white balls, X white balls, right, and 3 minus X red balls, right, isn't it? Is given by R of sorry, rupees rather, rupees rupees, okay, should be 4 into rupees. You draw x, you'll have this much, plus you draw red, you'll have 3 minus x, right? So that would be the total reward, right? So let's write down the distribution of that also. So let's draw a table, a very big table perhaps. So 1, 2, 3. Okay. So what do we get? This should be equal to x. Okay, so let me make another table here, right? So we have x, we have p of x, and then we have reward rx in rupees, right? This was 0, 1, 2, 3. This was 1. What was that? This is p of 0 was 1, 5 over what was that? I don't know. 5 or something. 5 or 30. Yeah, this was 5 over 30, then this was 1, right? So 15 over 30, then this was 9 over 30, and this was what, 9 over 30, and this is 1 over 30, right? So how do we calculate the reward, right? Reward would be, I'm drawing 0 white balls, all 3 red balls here, so it will be 3 into 6, that would be 18. Here I'm drawing one white and two black, right? So two red rather. So this will be 4 plus 12, right? 4 plus 12 is 16 if I'm not wrong, right? Here I'm drawing two white, so 2 plus 4, right? 4 to the 8, 8 plus 6, 8 plus 6 is 14 if I'm not wrong, and then I'm drawing no red, so it's all three white, so this is the 12, right? So therefore expected number of expected Rx, isn't it, would be equal to the corresponding probability distribution multiplied by the rupees, right? This is this is equal to summation, right? This is Rx into Px, right? So this is 1 by 30, again I can take out. This is 18 into 5 plus 15 into 16 plus 9 into 14 plus 12 into 1, right? So if I do a little bit of calculation here and there, what I get is this is equal to 15.60 rupees, right? That's the expected number of rupees, right? Well, thank you. We'll see more of problems maybe next time, or maybe during class hours. This is the end of the chapter, right? We'll look at uh, more of distributions, right? Maybe next time. Thank you.